Welcome to tonight's video we'll continue on recursive and explicit definitions for sequences. First, let's talk about factorials and some interesting facts about factorials and like what does it mean to be a factorial. First of all, a factorial is just the product of consecutive integers. For example, if we say 5 factorial, that means 5 times 4 times 3 times 2 times 1, and that's equal to 120. So if we say n factorial, we mean that it's n times n minus 1 times n minus 2. And depending upon what n is, it could go all the way times to 1 factorial. To 1. Some special factorials, for example, 0 factorial is 1. And in class, we talked about combinations and how 0 factorial has to be 1 in order for that to work. And 1 factorial is also 1. And here are some examples of factorials in sequences. For example, if b sub n is 2n plus 1, then the first term, 2 times 1 is 2, plus 1 is 3 factorial, which is 6. All right. Also, if you look at a sub n equals n factorial, the first term is 1. Second term, 2 factorial, is 2 times 1, which is 2. The third term, 3 factorial, 3 times 2 times 1 is 6. The fourth term, 4 factorial, 4 times 3 times 2 times 1. So notice all we're doing is multiplying by the next number each time. So notice 1 factorial, 1. 2 factorial, just multiply by 2. Multiply by 3, multiply by 4, multiply by 5. So if you're looking for a recursive definition for a sub n, it's a sub n plus 1 equals a sub n times the next number, which is n plus 1, where a sub 1 equals to 1. That is the recursive definition. So if you look here, the first 5 terms of this sequence, going back to recursive definitions, the first term is 43. So you're adding 5, so that means the next term is 48. The next term is 53. The next term is 58. And the next term is 63. So the 3 terms are 43, 48, 53, 58, 63. For the next one, notice even though it's n plus 12, n plus 10, n plus 11, think about what it's saying. It's saying that to find the next term, you need to take the one that was 2 before it, subtract it from the one that's previous, and then add 1. So for example, if you're finding the third term, you want to take the first term minus the second plus 1. So that means that since b sub 1 is 2 and the second term is negative 1, that you would take 2 minus negative 1 plus 1. So the third term is 4. So to find the fourth term, you would take the second term minus the third term plus 1. So you would take negative 1 minus 4 plus 1, which would give you, so you have negative 1 minus 4, which is negative 5, plus 1, which would give you negative 4. And to find the fifth term, you would take the third term minus the fourth term plus 1. So you would take 4 minus negative 4 plus 1, which is 9. So the 5 terms are 2, negative 1, 4, negative 4, 9. All right, so then next, it says find the first 5 terms of the sequence where to find the next term, you take 2 times the number of term times the previous term plus 3. So since the first term is -4, to find the second term, that means you go 2 times n, which is 2, times the previous term, which is -4, plus 3. So that gives you 4 times negative 16 plus 3, which gives you, or sorry, made a mistake there. If you're finding the second term, since it's n plus 1, n equals 1. So it's 2 times 1. So 2 times -4 plus 3, which is -5. The third term, that means n is equal to 2. So it's 2 times 2 times the previous term, which is -5 plus 3, which gives you -17. And the pattern continues. If you're finding the fourth term, n is 3. So 2 times 3 times -17 plus 3, which is -99. And to find the fifth term, n is 4. So it's 2 times 4 times -99 plus 3, which is -789. So those terms, the first 5, are -4, -5, -17, -99, and -789. So number 4 says determine the explicit and recursive definition. And we've talked about in class for explicit, if you're adding 6 or adding the same number, that 6 is going to be part of it. And if you're adding the same term, it's also a linear equation, like y equals mx plus b. So that 6 is the slope. The 6 is the slope. So now you have to ask yourself, well, what number did I have to add 6 to get to 49? And that is 43. So your explicit definition is 6 times some number plus 43, because you keep multiplying or keep adding 6. So the explicit definition is 6n plus 43. The recursive, this is the explicit. The recursive, well, you just add 6 from the first term to the next. So to get to the next term, you take the previous term plus 6, and you start with the first term as 49. So that's the recursive, and that's the explicit. So remember, if you're adding the same number, it's a linear equation. Now here in the next one, we talked about how, since we're multiplying the same number from term to term, that it's going to be an exponential equation, because we're multiplying by -1/2, so we're going to be multiplying by powers of -1/2. And the first term is 6. That means we have -1/2 to the 0 power, which means the explicit definition is going to be 6 times -1/2 to the n minus 1, because if n is 1, the first term, 1 minus 1 is 0, and that'll give you 6. Whereas a recursive, that just means that we start, to find the next term, we take the previous term and multiply it or divide it by 2, or multiply it by negative 2. And that is where the first term is equal to 6. So the next one, the next one is not as straightforward. So here you notice you're multiplying by 2, then by 4, then by 16. So if you notice in the recursive definition, which might be easier, to find Cn plus 1, the next term, you are basically going to take the previous term and square it. Because notice 2 squared is 4, 4 squared 16, 16 squared 256. And that means you're going to start with the first term that's equal to 2. The explicit is not as easy. You just have to recognize that this is 2 to the first, 2 to the second, 2 to the fourth, 2 to the, basically 2 to the eighth. So if you notice, with the explicit definition, C sub n is equal to the power of 2 to the n minus 1. And that one's a tough one that you just kind of have to look at and recognize. For number 7, it's a little easier because notice you're multiplying by -2 to go to term. So this is an exponential one for the explicit. Notice your first term is -7, and then you're raising -2 to the n minus 1 power. And for the recursive, we're just multiplying from term to term by -2. So we take -2 times the previous term, where the first term is -7. And then for number 8, to find the explicit definition, notice you're adding 4, you're adding 7, you're adding 10, then you're adding 13. So notice it's a constant amount that it's going up by, as far as you're adding 3 more than you did the previous time every time. So that means it's a quadratic. So that means d sub n is going to equal some an squared plus bn plus c. So once again, we can do this by matrices because the first term is -12. So that means a plus b plus c equals -12, because if you put 1 in for n, that's what happens. The second term is -8. So it's 4a plus 2b plus c equals -8, because you put 2 in for n. And the third term is -1. So it's 9a plus 3b plus c equals -1, because you put 3 in for n in that case. So remember your matrices, the A matrix is just the coefficients of A, B, and C. And for these type of problems, this matrix is going to be the same: 1, 1, 1, 4, 2, 1, 9, 3, 1. The X matrix is just the variables A, B, C. And then the B matrix is the answers, -12, -8, -1, or the terms. So remember, AX equals B. So that means X is going to equal A inverse B. So then you do this on your calculator. And remember, you go second matrix, and you're going to edit the 3 by 3 if you haven't put it in. If you have already, then the 3 by 3 of A should be the same. Let me just move this so I can type it in. So I edit it, and notice I already have it typed in, so I'm just going to quit that out and go second matrix, and now I'm going to edit B and make sure, oh, I didn't edit it, I just selected it. You got to go to edit, select, and so change the numbers to fit what you need, which is -12. Move it down, -12. It is -8. And last but not least, -1. Oops, sorry. All right, so that is the 3 by 1 matrix that you need. So then you go quit, clear that, second matrix, and then select A, then hit the inverse, and then second matrix, and hit select B, and then hit enter, and it gives you the coefficients for the quadratic. So it gives you negative 1/2, or sorry, negative 1.5, negative 0.5, and negative 13. So actually this is a positive 1.5, negative 0.5, negative 13. So that means your quadratic d sub n is equal to 1.5 n squared minus 0.5 n minus 13. That is your explicit formula. All right, I hope you've enjoyed the second part of the recursive and explicit definitions, and hope you've enjoyed your Labor Day weekend, and I will see you in class. Have a good evening.